This is the lecture over your assignment number 6. It's topic 4.4 through 4.3. We're going to talk a little bit about slope of a line. So the slope is the ratio of the rise to the run when moving from any point on the line to another. So we use this expression or this formula to represent the slope. If you're given two ordered pairs, this would be like the first ordered pair and the second. That's what those little ones mean in little 2. It's just meaning setting it apart. This is the first ordered pair and this is the second. We would take the second y and subtract the first y and put that over our second x and minus our first x and then simplify. And that's going to give us our slope. So let's practice that with example 16. So remember this is my first x and my first y in this point, and this is my second x and my second y. So what we do is we take our second y and we subtract our first, and we put that over our second x and we subtract our first. So 7 minus 4 is 3, and 5 minus 2 is 3. Excuse me. And so we would want to reduce that. That would be like saying 1. So my slope is 1. Basically, if you had a line, it wouldn't be this one exactly, and let's just say that those points would be on that line somewhere. It just means that you're moving up 1 over 1, up 1 over 1, and you're landing on that line every time. You also could do 3, 1, 2, 3, 1, 2, 3. But we would want to reduce it because moving a shorter distance and landing on the line is a lot easier than moving 3 and over. It also keeps the points closer together. Let's go and look at example 17, another one. Our second y minus our first. Be careful because our first y is also a negative, okay? So you have a double negative there that we'll have to fix. Remember that double negative rule. And then we would do our second x, 10, minus our first x. And again, that is a negative, so negative 5. Okay, so remember your double negative rule. If you weren't looking at it like that, that's kind of like saying the opposite of negative 3. But hopefully you've memorized the fact that a negative and a negative means that they both become positive. So we have 6 over, again down here, they both become positive. Again, what we would want to do is reduce that because we don't want to move up 6 into the right 15. We would want to reduce it so we can move less spaces. So we know 3 can go into 6 2 times and 3 can go into 15 5 times. So the slope of that line would be 2 over 5. So that would be like going up 2 and to the right 5. So that's being able to find the slope of a line if you're just given 2 points. In the previous assignment, you know, when you're given an equation, you were graphing the line. This one, you aren't graphing the line yet. They're just giving you 2 points to find what the slope would be. And we use this formula. Positive and negative slopes. So if it's a positive slope, it's going to be going upward like this. You know, think about the stock market. We really like when the line goes up. A negative slope goes down. Slope of horizontal lines, this is a horizontal line, would be 0. Basically because there's no rise between it. If you were working with a fraction, it would look kind of like that. If you were trying to find the slope of that line and you're using 2 points and you plugged into that slope formula above, so basically the top would zero out because there's no rise between them. There's 0 rise. So 0 divided by any number is just 0. But if we talk about a vertical line, again, if you were doing the slope formula and maybe you had 2 over 0, we would call that undefined because you can never have 0 in the denominator. But we call the slope of a vertical line undefined because there's no run between the points in the vertical line. You're not going right or left, you're just going up. Okay, so what is the slope of a horizontal line? It's 0. The slope of a vertical line is undefined. We're just writing down to reiterate that again on the note. So we learned basically about slopes of a line, you know, how to find the slope, but now we're going to learn that what if you're graphing two equations. Sometimes the slopes may have a particular relationship, like parallel lines. Parallel lines have a particular relationship with their slope. So do perpendicular lines. They have a particular relationship with their slope. Any other lines, like intersecting lines that might look like that, that's not parallel or perpendicular. They don't have a relationship between their slopes. So like parallel lines, for instance, if you graphed this, let's just say that we graphed a line right there, and then right here, we graphed this. This would be an example of parallel lines. Parallel lines never, ever, ever cross. And if you notice, they have the same slope. We'd go up 1 over 1, up 1 over 1. Same here, up 1 over 1, up 1 over 1. So parallel lines have the same slope. Okay, what if we had, let's go ahead and do another line that looks kind of similar, taking it through the origin and just going up 1 over 1. But then I'm going to go backwards, maybe going through this point and going down 1 over 1, down 1 over 1. So perpendicular lines, if I had a straight edge, I don't have one with me today, they cross at a 90-degree angle. So I don't know if you remember, a lot of times when we'd see a 90-degree angle, we'd do this. And they have opposite signs of their slopes and they're reciprocals of each other. So sometimes we'd call them opposite reciprocals. But if you think, like if we're going up 1 over 1, up 1 over 1, the slope of this line would be 1. If we were going down 1 over 1, down 1 over 1, the slope of this line is a negative 1. Okay, so it's kind of hard to think of that as a reciprocal because 1 over 1 is just 1 over 1 and we can't flip that. But I'll talk a little bit more about it in the next example. So if we look at example, or I'm going to actually give you a different example. So if I were to say that I had a slope of 2 over 3, just to kind of help you with understanding slopes of perpendicular lines, the slope of the other line, not these, this is not an example of a line with a slope of 2 over 3, the slope of the other line, you would flip it and give it the opposite sign. So these two would be said to be perpendicular. Without even graphing them, we would know that. So parallel lines have the same exact slope, perpendicular lines have opposite signs, and they are reciprocals, or you can write, we flip it. So let's go down here. It says, are the lines y equals 2 over 3x plus 3 and y equals negative 3 over 2x minus 5 parallel, perpendicular, or neither? So again, we learned in the last lesson that the number in front of x represents the slope when it's in an equation form. When it's in slope-intercept form, meaning your y is by itself. So we can already identify the slope of this line. So the slope of this line right here is 2 over 3. And the slope of this line right here is a negative 3 over 2. So we want to identify, are these parallel, perpendicular, or neither? And actually we can already tell that this is 2 over 3, a positive 2 over 3. This is a negative, so it's opposite signs, 3 over 2. So we could say, without even graphing this, that these are perpendicular lines because they are opposite reciprocals of each other. Their slopes are. You also could graph them. So remember, in graphing, if I were graphing this line using slope-intercept form, I would plot my first point at 3. And then I could go up 2 and to the right 3. Up 2 and to the right 3. And that gives me that line. I could go plot this other line, and I'll do it in red. So I have a negative 5. So I could go, you could apply that negative to the top or the bottom. I'm going to apply it to the way it looks right now. So I'm going to go down 3 to the right 2. Down 3 to the right 2. You could have also said 2 over negative 3. So you could have went up 2 to the left 3. Up 2 to the left 3. Okay? And it looks kind of like that. I know my line isn't great. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. So these are supposed to be perpendicular lines. My lines are not perfect, so you'll understand that there is a little human error. So if you have straight edges and if you're graphing them just right, you don't get a hairline off like mine. This line is kind of going underneath the points. It would look perpendicular. It would cross at a 90-degree angle. And I mean, that doesn't really look like a 90-degree angle, but it is. Okay? And actually, like this one, I really went below those points. So that's an example of a relationship of two equations that we could tell before even graphing them that the lines would be perpendicular from their slopes. Let's look at this other one. It said, are these lines parallel, perpendicular, or neither? Again, we're looking at the slopes. So I look here and here, and since the slope of this line is -4 and the slope of this line is also -4, that means they are the same slope, which means they would be parallel. Parallel lines. Let's go see how that works. So these equations look very similar, but our starting point here is a +3. So I would go, since my slope is a -4, think of it like 4 over a +1. So if the top is negative, we'd go down 4 to the right 1. Down 4 to the right 1. And so that would look kind of like that. I didn't do very good. Again, I really kind of need a straight edge, but hopefully you have one and you do better than I do. My other line is a -3, starts here. And again, we have the same slope, down 3 to the right 1. Or not 3, 4. Down 4 to the right 1. Down 4 to the right 1. Or you could trade and call it 4 over -1. 1, 2, 3, 4, so we went up 1 to the left, or up 4 to the left 1. So again, you know, my first line was really bad. So it really looks like that maybe somewhere up here they would cross, but they're not going to. If I could just do this, I will do a better job to demonstrate that. Okay. So it's actually going perpendicular. So if you have a straight edge, it really does help a lot. Kind of, it's deceiving because, you know, when you're graphing, especially freehand, there is human error in graphing. So that shows that those two lines would be parallel. So we're learning in this topic about the relationship between slopes, and the only relationship that we have is parallel and perpendicular lines. Any other problem, like let me see if we have on the next one. If their slopes are not opposite reciprocals of each other or the same, then we would say that they're neither. In this equation, we can't identify the slope yet. So you have to put it in your slope-intercept form, meaning you need to isolate your y first. So I'm going to rewrite both problems since I wrote there, and then so I can show my work of putting that in slope-intercept form. So I would want to isolate y. This is the term I'm trying to get by itself on both of them for right now. So the first thing I would do is move my 2x over. Since it's a positive 2x, we're subtracting 2x. So we have 3y equals a negative 2x, and that's a positive 2, so plus 2. So remember, those are not like terms, and we like to put our term with a variable up first, and then that constant on the end. Now, to finish, we need to divide all those terms by 3. So we get y equals a negative 2 over 3x plus 2 over 3. All we really care about for this problem, because we're answering if these slopes are parallel, perpendicular, or neither, is what the slope is there. Let's look at the other and do the same. So again, I want to move this over. I would do it by subtracting 2x again. So when I bring this down, don't forget that had a negative with it. So I have a negative 2x minus 4. To get our y by itself, we would divide everything by a negative 3. So I have y equals negative, and a negative makes that a positive 2 over 3x. Negative and negative makes that a positive 4 over 3. So again, what we're doing is comparing the slopes only when we decide if these lines are parallel, perpendicular, or neither. These two do have the opposite signs, but they are not reciprocals. Okay, so they are not perpendicular, and obviously they're not exactly the same. So they're not the same side, so a couple notes. So obviously, I mean, they are 2 over 3, but one's negative, one's positive, so it can't be parallel. So we would say that this would be neither. This one would just be 2 lines that intersect, you know, maybe something like that, not at a 90-degree angle. So you might have a couple questions that says find the slope of a line parallel to a line through these points. And if you do, that means we need to first find this slope. Remember, the slope is taking your second y minus your first y, it's on the page before, over your second x minus your first x. So I'm taking 5 minus a negative 3. So in the formula there's a minus, but my y was negative, be careful of that, and 8 minus a negative 1. So remember, since you have 2 negatives, they both become positive. They cancel out. And it's just like saying 5 plus 3 is 8, and 8 plus 1 is 9. But what we need to do now is say, what's the slope of a line parallel to the line that ran through these points? So this is some line, we don't have to graph it, but any other line that runs parallel would have the same slope. So we would say any other parallel line has the slope of 8 over 9. We don't know any points on that line, but any other parallel line has the same slope. So we don't change it. The next one says find the slope of a line perpendicular to the line that crosses these points. So again, first we have to find the slope of this line, then we can say what any line parallel could be. So I take my second y minus my first, negative 4 minus 7, and my second x minus my first, which is a negative 4. So these are same signs, so we really add and we get negative 13. Actually, I added wrong. It's 11, I apologize. And these are same signs here, or double negative, not same signs, a double negative, so we need to make them positive, and 6. So I can't reduce that or anything, so I don't, but I need to ask myself, what's the slope of any other perpendicular line compared to this? So we would have to flip it and take the opposite sign. Since this is negative, we know this is purposely positive. You don't need to put a plus sign in front of it because it's understood it's positive when you don't have a minus sign in front, calling it negative. And then another way of comparing these problems that you'll see in the homework is it'll say the line that contains these points, is it perpendicular to the line that contains these points? So let's call this line A and this line B, just to give it a name so you can separate. You don't have to graph it, you just know this is a line running through these 2 points and this is a different line running through the 2 points. So slope of your line A, we take negative 1 minus 2, our second y, minus our first, over x minus our first x of negative 3. And so negative 2 and negative 1 make a negative 3, and we have a double negative on this one, so that would be positive 7. So the slope of line A is a negative 3 over 7. Let's look at line B, that second ordered pair lines that are going through those lines. The line that's going through those second ordered pairs. So my second y, negative 4, minus my first, over my second x, negative 2, minus my first. So negative 4 and negative 3 make a negative 7, and negative 2 and a negative 1 make a negative 3. Simplifying that, that would be 7 over 3. So the slope of that line B is 7 over 3. So remember what we're comparing to know if it's perpendicular. That's what it asks in this question, so you have to particularly remember that relationship. The slope of this line is negative 3 over 7. So they are opposite signs, and they are reciprocals. So yes, these lines, if you graphed them, if you graphed those points and drew lines through them, they would be perpendicular. The last part of this assignment, you will be finding an equation of a line. You might be given a 1 point and the slope. And so we can use what's called point slope formula. It's here in the top, written in bold, to find the equation of the line. Also, if you're given two ordered pairs, you should be able to, because you can find the slope and you have at least one ordered pair. So you need to have at least one ordered pair and the slope, or be able to find the slope from two ordered pairs to be able to do this. So we show one of each kind. So what we're going to say is this would be our first ordered pair. So when you say y minus the y1, that's like a sub 1, just by the way, it looks like a big one, equals m times x minus x sub 1. What this means is you're given y and you're given x. Everything else is from up here. Your y stays the same and the x stays the same, and then we can plug in our slope too. So everything I've highlighted in yellow are things you can plug into this to find the equation of the line. So we say y minus whatever my given y is, so in this case it's a 2, equals, I know my slope, remember m equals -3, so -3 times x minus my given x, which is a -1. So if you'd like to see that information listed over here a little bit more, you could, but that's what we plugged in, these three things into this equation. Then you need to turn it into slope-intercept form. So all that means is we want to get y by itself. So your next step would be get y by itself after you've done this. Okay, so I'm going to move to the right since I wrote underneath. So y minus 2 equals -3 times x is a -3x. And I should have said this. Remember, you always want to fix your double negatives so that when I distribute, here we go, -3 times a 1 is a -3. Our last step in getting y by itself was just to add 2 over. So we get y equals a -3x minus 1. So all we did was replace what we knew we could plug into that formula. Let's go on to the next one. So again, I'll write the formula. Y minus our given y equals m, which is our slope, times x minus our given x. But the only thing about this one is they don't give us the slope this time. But they do give us enough information to find the slope. So the first thing you need to do is find the slope in this example, because you were given two ordered pairs rather than up here you were given a point and the slope. So you get to do a little extra work, but we can do it. We have 2 minus a -2 over 4 minus 5. So we have our double negative. Let's fix that. 2 plus 2 is 4 over 5, or 4 minus 5 is a -1. Let's clean that up. So that means the slope of that is really like a -4. So our slope is a -4. But then you might be thinking, oh, which ordered pair do I use? I have 2 of them. It doesn't matter. I generally just use the first one. So I'm going to say for my given x, I'm going to use 5, and for my given y, I'm going to use a -2. You can try it with 4 and 2 and you'll get the same answer. So let's go plug these things in to where we're supposed to plug in the given information so we can make our equation. So y minus, because that's from our formula, our given y, which was a -2. M is my slope, -4, times x minus my given x, so that's a 5. So before I start distributing, I always do like to fix those double negatives first. I didn't above, I mislooked it. So we could say this is like saying y plus 2 now, and we could distribute. Negative 4 times x is a negative 4x, and a negative 4 times a negative 5 is a positive 20. Now to get y by itself, because that's the form we need it in, slope-intercept form in the end, isolate your y, we would subtract y, so we have negative 4x plus 18. So we're only needing to find the equation. We don't have to graph these.